Hello, in this video we're going to look at some applications of exponential functions. Our first one is finding the amount that results from an investment of $400 invested at 4% compounded daily for 2 years. So compound interest is going to be one of two formulas. We're going to have A equals P times 1 plus R over N to the NT. This is going to be for compoundings that happen at a set interval, where N is the number of times per year that the compoundings occur, R is the interest rate, T is the time in years, P is the principal investment, and A is the amount at the end. Or we'll use A equals P e to the RT, and that's going to be where you have continuous compounding. And the A, P, R, and T are the same from the previous equation. All right, so if we want to find the amount that results from an investment of $400, so that's going to be our principal investment, that's going to be our P value, invested at 4% compounded daily, so that's going to be our R, but remember we always want to do R as a decimal. And then our time in years is our T, so if we want to find the amount, that means we're looking for A. Our principal investment is $400. This is compounded daily, so that's telling us that N equals 365. R is 4%. 4% as a decimal is 0.04 divided by 365 raised to the R, or to the N times T, so 365 times 2 years. And then this is just a plug and chug as far as the calculator. So we'll plug in 400, open parentheses, 1 plus 0.04 over 365. You do not have to put that fraction in parentheses because your calculator will follow order of operations. But if you do put that fraction in parentheses, make sure that you close the parenthesis that you opened here on the 400 before you raise it to that exponent of 365 times 2. All right, we expect something a little bit bigger than 400 because we are starting with 400 and earning interest, but it's in 2 years, it's not going to grow a whole lot, so 433.31 is a reasonable answer there. All right, what if we want to find the principal needed? That's our principal investment. So we're finding P needed to get 3,000. That's going to be our A value in 1 3/4 years. So that's going to be T. At 10%, that's going to be our R. Remember, we want to convert that to decimals. And then compounded monthly means that N is equal to 12. It's going to happen 12 times per year. So here, since we do have an N value, we're going to use that first formula, same formula again. We're looking for P this time though. So our A is 3,000. We're looking for P. 1 plus R is 10%, so that's going to be 0.1 or 0.10 divided by our N of 12. And then 1 3/4 is the same thing as 1.75 times 12. So I put T first, but we're multiplying, so it's going to be the same thing. Now you can do this in 2 steps. You can find what's multiplied by the P and then do 3,000 divided by that, or you can plug in your calculator 3,000 divided by that exponential part. I'm going to go ahead and do it in 2 pieces. So I'm going to first find that exponential part, so 1 plus 0.1 divided by 12 raised to the 1.75 times 12. So that's what's raised, or what's multiplied by the P on the right-hand side. And then I want to do 3,000 divided by that answer. So to get answer, you're going to do second and then the minus sign on the bottom. And we expect this number to be smaller than 3,000 because it's going to grow to 2,000 or to 3,000. But it's not going to be considerably smaller because we're only doing this for a little under 2 years. So we do get 2,520 and 20 cents. So 2,520 and 20 cents. All right, our next example, how long does it take for an investment to double in value if it is invested at 17% compounded quarterly? So how long means that we're going to be looking for T. Here we are, on this first part at least, we are compounding it quarterly. And so that means that N is going to be equal to 4. So we're going to use the formula A equals P times 1 plus R over N to the NT. We know R is going to be 0.17, but that's all that we have. We don't know our A and our B, and we're looking for T. But it does tell us how long does it take for an investment to double. So what that means, that's telling us that A is equal to 2 times P. If you want to go ahead and plug in a value, you can. We'll see here in just a minute why it does not matter what P is. It's going to take the same amount of time for an investment of $100 to double in value as it does an investment of $1 million. It's going to take the same amount of time. All right, so our A is going to be double our P. R is 0.17. N is 4. And then 4 times T. We are going to solve this for T. Before we can solve this for T, we need to get that exponential part by itself. So we need this part by itself. Divide both sides by P, and we get 2 is equal to that parenthesis. And then we can take a log of both sides. It really doesn't matter what log we use. If you want to, you can use log with the base of 1 plus 0.17 over 4. But I'm going to go ahead and just use the natural log. Take the natural log of both sides. So we'll get the natural log of 2 on the left. And on the right-hand side, the benefit of taking that natural log is we can use the power rule to bring that exponent down front. So we can write that as 4t times the natural log of what's inside that parenthesis. And then to get t by itself, we're going to divide both sides by 4 times the natural log of that parenthesis. So we get natural log of 2 over 4 natural log of 1 plus 0.17 over 4. And we want to make sure when we enter this in our calculator that we put parentheses around that denominator. All right, so we'll get natural log of 2 divided by, we need to open parentheses for that denominator or use the alpha y equals 4 times the natural log of 1 plus 0.17 over 4, close parentheses on the denominator. And so we get t is equal to 4.16, and t is always in years. So with 17% interest, it's not going to take too long for that investment to double. And then as we saw, our first step is to divide by that P, so it doesn't matter whether we're talking about an investment of $1 or an investment of $1 million. It's going to take the same amount of time to double. All right, if we're doing the exact same thing, but it's compounded continuously, the only thing that really changes is the formula that we start out with. We're going to have A equals PE to the RT. Our A is still going to be equal to 2P. And our interest rate is still going to be 17, and we're still looking for T. Again, our first step on this one is to get that exponential by itself, so we can divide both sides by P. And take the natural log, just like we did on the previous one. This one we definitely want to use the natural log because our base is E, and that right-hand side is going to simplify to just the exponent of 0.17 times t, And so our t value is going to be the natural log of 2 over 0.17. Now in this, since something is happening continuously, happens more often than something happening quarterly, we're going to earn interest on our interest a little bit faster. And so this one, we expect it to happen in a little bit shorter time frame. So we look for something a little bit smaller than 4.16. So natural log of 2 divided by 0.17 is 4.08 if we round it off to the nearest hundredth of a year. So we do see that it happens a little bit faster with the continuous compounding. All right, now let's talk about mosquitoes. The population of a colony of mosquitoes obeys the law of uninhibited growth. So the law of uninhibited growth is actually that continuous compounding formula we were just looking at. The letters sometimes are a little bit different, but the setup is always going to be the same. We're going to have the amount at the end, the amount at the beginning, times e raised to whatever that growth rate is going to be, times our time. All right, so if n is the population of the colony and t is the time in days, we want to express n as a function of t. So that's going to be our left-hand side. N is going to be a function of t. The original amount is going to be n sub 0 or n naught. And time is t. And then k is going to be the letter we're going to use for our growth rate. So we're going to get n naught times e to the r, or to the k, t. And so that is going to be our formula here. It's in the same exact form. Uninhibited growth just means that it's that same basic setup, but different applications are going to use different letters to represent the different quantities. All right, so if there are 1,000 mosquitoes initially, so that's giving us our n naught, and there are 1,600 after 1 day. So that means when t is equal to 1 day, our n of 1 is going to be equal to 1,600. What is the size of the colony after 2 days? Well, this is actually a two-part question because we don't know what k is. We need to figure out that k first, and that's what we're going to use this information for. And find that k, and then we can plug back in. All right, so n of 1 is going to be equal to 1,600. So our n is 1,600. We've got 1,000 to start out with. E to the, we're looking for our k, and we're going to use t is equal to 1. It does not matter here what units you have on your time as long as you stay consistent. So this one's going to be 1 days. We're going to make sure that our answer is going to be in days on this. All right, just like on the previous one, our first step is to get rid of what's multiplied on that e. So we'll divide both sides by 1,000. We'll get 1.6 equals e to the k. And then just like on that previous example, we're going to take the natural log of both sides. And the natural log of 1.6 is now going to be equal to the natural log of e to the k. The natural log and the e are both the natural base e. One's a log, one's an exponential. They're going to cancel each other out, and we get that our k value is going to be the natural log of 1.6. And so if we plug that back in, we can find how much is going to be left after 2 days. So n of 2 is going to be, we're still started with 1,000. Our k value is the natural log of 1.6, and now we're looking at 2 days. And so if we plug in 1,000 times e to the natural log of 1.6 times 2 days gives us 2,560 mosquitoes. All right, how long until there are 70,000 mosquitoes? So 70,000 mosquitoes now is going to be our number of mosquitoes. That's what's going to go on the left-hand side. We start with 1,000 mosquitoes. Our k value is still the natural log of 1.6, and now we're solving for t. So again, the first step, this is going to be just like what we did this first part of this previous example. We want to divide by 1,000 first, and so that's going to be 70 equals e to the natural log of 1.6 times t. And we can take the natural log of both sides. That's going to give us the natural log of 70 on the left, and the natural log of the exponential base e is going to simplify to just that exponent. And so we get the natural log of 70 over the natural log of 1.6 is going to be our time frame. So the natural log of 70 divided by the natural log of 1.6 gives us 9.04. And our units on this are still in days. So it's only going to take a little more than 9 days to get 70,000 mosquitoes. All right, I'll see you guys next time.